Peer-led team learning has advantages over the previous methods that we implemented before. It relies heavily on student interaction, both peers in the same class, as well as peer leaders, students that already had the experience of taking the class. And this opens a wider channel of communication between the students learning and the students helping. And this doesn't happen that often between a student and a professor, but it does happen between a student and a peer leader. And also the fact that we have, in my case, I have over 140 students, would make it impossible for me to maintain a direct communication line with all of them. So what we do is we have a small army of students helping us, the so-called peer leaders, and they have their own workshops, each of those with 15 students or so, and they work for 2 hours every week. And some students go as far as to go to 2 workshops per week in order to gain more experience.
Go ahead, guys. Today we'll be covering Ampere's law and Biot and Savart's law, and we'll be doing a few problems within our groups.
I'm going to say too, well, you're considering this loop, right? So you have this amount of current going through there. But at the same time, what's happening with this current? Are they opposing each other? Do you see that? E times IR, right? That one somewhere there. Blood's getting easy.
Going back substitution.
This two and this one, right? But you have another loop, don't you? And in this other loop, you have a current I3.
I do enjoy being a peer leader. It's helped me academically as well as socially.
This guy, Demetrio Corrales, is one of our students. He's here from El Paso, and he's a physics major. Last summer, he spent part of the summer doing research on gravity waves at Washington State. And he has been my peer leader for 3 semesters now,
yeah,
perhaps, but
4 now.
4 now, and I've been able to tame most of my peer leaders except Demetrio. Demetrio is still his own character. He's very well liked by the students, even though, for my taste, he tries to be, you know, a little bit on his own. Not following the rules as much as others do, but that is still fine, and he does a good job, and he gets excellent evaluations. So I suppose that he's doing whatever is needed. One of the problems that I see is that the students in urban settings like El Paso tend to work. They are not the usual typical college students that live in dorms. They come for a few hours to the university, and then they have to fly away, go out of campus to work, and then they also have a social life. And in the evenings, they go and see the boyfriend, girlfriends, and they have families, and they have to help support the family. So because of all of that, it is really hard for them to develop these type of networks that help students rely on one another to understand concepts, difficult concepts like physics. So what we're doing is basically carving time out of their busy schedule and giving them the chance of finding friends, discussing concepts. Through our workshops, we give them 2 hours of straight practice on all of these concepts, all of these type of problems, and they end up developing this network that is extremely useful for them to survive in this environment.
Well, I teach the first semester of engineering physics, which is mechanics. And I've got a big auditorium with around 250 students. And we meet twice a week for an hour. So then we break them up into groups. I've got 15 sessions with about 9 peer leaders that we meet with the kids in small groups, 15. And so that's the whole concept, is that we get undergraduates to teach these smaller groups, these workshops, and hopefully they can relate to the students and have the students do problems and that kind of thing. I think we're stuck with the big classes. I think economically it's going to be a problem to go back to a class of 30 students. It uses up too many professors. So you're stuck with the big class, so how do you make it work at least somewhat? Well, you break it into groups and you meet with the small groups and you work out a lot of things that you can't do in the big classroom. The whole concept is peer leaders, which means that we have undergraduates monitoring undergraduate students. And it works out pretty well. They relate to these kids, and it's a great experience for them also, in the sense that they get to be in front of an audience and talk about physics. And they learn stuff. I've been here a long time. And I started when I was a very young man. And I've never left here. So I've retired several times.